In this video, we're looking at an average number of miles driven on a full tank of gas for a certain car model is 373, and assuming the mileage follows the normal distribution with a standard deviation of 43, complete parts A through D below. Part A, what is the probability that before the low fuel light comes on, the car will travel less than 400 miles on the next tank of gas? So this is X. And we want to know the probability that X is less than 400. So we do not have a z-score yet, so we have to convert this to a z-score, and I have the formula to the left. So it's going to be X, which is 400, minus the mean, which is given to us, divided by the standard deviation, which is also given to us. We're going to round our z-score to 0.63, and then we're going to use Excel to find the probability that z is less than 0.63. So the way that we do that is we know we have all of our information, and technically you don't have to convert it to a z-score. You could technically skip that step, but I do want you to know how to convert it to a z-score, especially for the well, actually, let's use norm.s.dist so I can show you with the z-score, because they want us to use technology and put the z-score in as 0.63. So norm.dist, you put in the x value straight in, but they want us in the homework to go ahead and get the z-score and use this formula instead. That way you can make sure you get the right number, like the right rounded part of the number. So that would be 0.7357, which is acceptable. Okay, now let's do it. It may accept both answers. So if we do norm.dist and put in X was 400. The mean was 373. The standard deviation is 43. And we want it to be cumulative because we want it all the way up to 400. So here you're going to get 0.7350. So you can work it either way. All right, you can get the z-score and use the z-score and use the norm.s.dist formula, or you can just plug it straight in without having to get the z-score. To save time, since both answers are acceptable, I'm going to skip the z-score step. Just make sure you're able to calculate that. All right, the car will travel more than 315 miles on the next tank of gas. So this time, I'm going to leave my formula in, and I'm going to put in 315. And this is going to give me less than 315. So if I want to know more than, I have to use the complement rule. And you will get, I may have plugged it into the wrong, yep, I plugged it into the wrong number. This is where I should have put 315, and I need to put this back as the mean. What was the mean? 373. Okay, so 0.9113 would be more than, which is what you get here. All right, between 315 and 335. So first we need to do 335, which is the larger one. Then we need to do 315, which is a smaller one, and subtract the area under the smaller number because we don't want to include that. And we talked about that. I think I may have erased it. But we talked about that in an earlier video about how if you want to know in between, you find the area of the larger and you get that. And then to find the area of the smaller, you're going to subtract it out so it ends up being in between. So let's look at it. And the best thing to do would be to put the mean and the standard deviation in your spreadsheet so you don't have to keep looking back at it. So 373 and 43. Let me make sure that's right. Okay, yeah. All right, so for this one, equals norm dot dist. It's the first one. All right, x for the first one is 335. The mean is 373. And the standard deviation is 43, and we want it to be true. All right, and I think they want us, we'll just round it to 4 decimal places. Let's do the same thing here. And x is 315. The mean is 373. The standard deviation is 43, and it's cumulative. All right, now we're going to take the area of the larger and subtract out the area of the smaller, and that will give us the area of the in-between. So we get 0.0997. All right, for the next one, exactly 410 miles. Remember the rule here, that would be 0. Because for a continuous probability distribution, if you want it to equal just one value, that probability would be so small that it would be 0. And I'm trying to find the slide real quick as a reference. Okay, because there are infinite number of possible values, the probability of one specific value occurring is theoretically equal to 0. So that will be the easiest question you have in this section.